Alright, so in this video we continue our discussion on linear programming. We were trying to solve example 9.1 of the textbook. We had this optimization problem where we wanted to maximize 2x1 plus x2 subject to two constraints, x2 minus x1 less than 4 and x1 plus x2 less than 8. So we implemented these three equations into the spreadsheet. We said for constraints, we only write the left side. We don't care about the right side for now. We have two other constraints that are always inferred. These are not usually given, but we have to basically imply that all variables are positive. So in this class, when we talk about optimization problem or linear programming, always variables are positive. So we don't say that, but you have to assume that all the variables are positive. Okay. So then we quickly covered how we can use this using Solver, but we could actually complete our discussion on that. So I'm going to show you one more time. You're going to go to Data ribbon here and then click on Solver. Then it opens up this window. We implement or refer to the cell we want to maximize. So here's the cell that I created already. Okay, that is cell B3. So let me just click on that one more time. I think this is a mistake. This should be B3. So I'm going to click on that. All right. And then I want to maximize this. I want to click on maximum, not minimum and not other things. Then by changing which cells, I'm going to change cell A2 to B2. So these two cells I'm going to change and put them in there. And then the constraints, I said one constraint is B4, right? So B4 should be less than 4. So this is the first time we bring in the right side of the constraint. So remember, I said when we implement them in a spreadsheet, we just implement the left side. So these equations have the left side evaluated with the guess values that I have up here. But when we implement them into this window, we have to give the right sides. So let me delete these constraints and write it for you one more time. So I'm going to add a constraint. There's nothing in there yet. So I'm going to click on Add. Then it says which cell need to be less than or equal to the constraint. So I'm going to say this cell, which I calculated already, that's 2A2, sorry. So first I'm going to click on the cell reference, then I'm going to click on constraint 1. So this has the constraint that I have here already. Okay, this should be less than or equal to 4. So I'm going to type 4 here. I'm going to add. So I'm going to add another constraint, which is x1 plus x2 less than 8. And the cell reference for this is going to be that guy. So I'm going to click on this cell this time, and less than or equal to 8. Okay, so I added two constraints here, right? Cell B4, which is this, less than 4, and B5 less than 8. So these are the constraints. This is the variable I'm going to change, and this is the objective function need to be maximized. Okay. Then here says make unconstrained variables non-negative. So this is the constraint, the non-negativity constraints that are always implied. We don't actually implement them here. We just check this box saying that yes, my variables are all non-negative. If you don't do that, that's a problem. Then you're not going to consider these two in a spreadsheet. Okay, so make sure you check that. All right, so then the method we're going to select is, so there's three methods here. We're going to pick simplex linear programming, simplex LP. All right. You can also give some options, like in terms of time. If you can say no more than 30 seconds spent to solve this problem. If you cannot, or if Excel cannot solve it in 30 seconds, then it's going to spit back an error message. So we're going to limit that just in case if something takes long, you don't want to have your laptop running spreadsheet for hours and not be able to solve the spreadsheet because you made a mistake somewhere. So it's always good to time the solution. So I'm going to put a maximum time of 30 seconds because this is a simple problem. So maximum 30 seconds will be spent on this problem, otherwise spreadsheet will quit. Okay, I think these are all fine. I'm going to click on OK, and then now we're ready to solve it. So remember, I start with the guess of 1, 1. So I'm going to solve it and see what I get back. So I'm going to click on solve. There you go. So the solution has changed. Now I get 2 and 6. That means this, with these two, I get maximum 28. So that means if you change x1 and x2, you never get anything more than 28. 20 is the maximum. You get 28 is the maximum of, oops. So let me just, okay, so then let me just and let this window go. So it says keep solver solution. Yes, so I'm going to keep it. If you don't want to keep these solutions, you cancel it. If you cancel it, it goes back to the initial guess that I put. I want to keep it because I think this is the solution I like. I'm going to click OK. So I kept the solution. All right, so let's go back. Oops. Let's go back to the problem one more time and analyze this. So this one says with x1 equal to 2, which satisfies all constraints here. So x1 equal to 2 and x2 equal to 6. You can check that it satisfies all these 4 constraints. It maximizes the y, which is supposed to be 28. That means any other x1 and x2 you use, any other x1 and x2 you use, you never get anything more than 28. 28 is the maximum by changing x1 and x2. So this is a very powerful tool that you have in Excel. It can maximize almost any linear function of any variable as long as everything is linear, subject to any constraint. So most likely next semester you're gonna need this technique to maximize or minimize. You can also minimize it. So you saw that in the objective. If you go to the simplex solver, you can also do the minimization here. I didn't do because this problem is about maximization. Okay, so this was example 8.1. Hope this is useful. Let's move on to example 2. So I'm going to close this and move on to example 8.2. So that is about optimization for a refinery factory. So let's go back to, yep. So we have a refinery, and this refinery generates or makes some products. And basically it makes 4 products, product 1, 2, 3, and 4. Every product has gasoline, diesel fuel, aviation fuel, lube oil. So these are lumped into product 1. So these are the fractions of the product. And if you add them up, you see that it's not 100%. So 25 times 2 is 75%, plus 15 is 90%, plus loss, that's about 91, right? Still doesn't get to 100. That means there are other things that it's not in this table. Well, we don't care, just to let you know that these are the fractions, and it's not necessarily add up to 1 because there are other things that are not in this table. Okay. So product 2 has 55% of gasoline, 20% of diesel, 50% of aviation fuel, 5% lube oil, and soap. Availability down here tells, I think this is the maximum that the factory can generate. So it can generate 20,000 barrels a day of product 1, 25,000 barrels a day for product 2, and so forth. Okay, so we have also another table down here. This is still problem 8.2. And this problem is talking about the cost. I have a processing cost, selling cost, and I think this is a typo. This should be maximum daily demand. Well, no, I think this is fine. You can still think of a minimum daily demand. That means the demand is always more than 38. Well, 38,000 barrels a day. The demand for diesel fuel is more than 18,000 barrels a day, and so forth, right? And these are the costs, I think, per thousand, per barrel. Yeah, this is what it says. This is the cost per barrel. Processing cost and selling cost for every component of the products. Okay, so what is the goal? The goal is we want to maximize the profit of the factory by saying how many barrels we have to produce from product 1, how many barrels for product 2, how many barrels product 3, and product 4. So number of barrels in each category is what we're looking for, such that it maximizes the profit. Okay, so let's go about solving this problem. First, we have to find the cost for each product, right? So let's say I'm assuming we have x1 barrel of product 1, x2 barrel of product 2, x3 barrel of product 3, and x4 barrels of product 4. And then the cost is going to be, to make this a bit smaller, so you can see both of them. So if there's x1 barrel of product 1, right? Product 1 has gasoline in it, diesel, aviation fuel, and lube oil. So for gasoline, I gain $56 per barrel and I spend 52. So the difference is the profit. So here's the difference, 56 minus 52 times x1. But x1 is the overall barrels of product 1. Product 1 has only 15% of gasoline. So this needs to be multiplied by 15%. So 15% of x1 will be gasoline for product 1, and this is the cost, this is the gain, the difference is going to be the profit. And then times 1,000, because these numbers are per barrel, and I want to get something 1,000 per barrel. Okay, the reason is some other constraint are 1,000, like this one is 1,000 barrels per day. So I'm going to convert all of them to 1,000 barrels per day. And as a result, if my x is per 1,000, then I have to multiply everything by 1,000 as well. Okay, so this is just the gasoline. How about the diesel? Diesel is 25% in product 1. So you're still in product 1. It's 25% diesel fuel. And then I spend $45 according to this table, and I gain $49. So it's the difference of 49 and 45 times 25%. And you can go ahead with the other two components, aviation fuel and lube oil for product 1. So this is all about product 1. And it gives me, if I have x1 barrel a day, this is going to be my total benefit in dollars. Okay, this much times x1. You do the same thing for other products, okay? And if you do this for product 2, then you get 5,050 of x2. For product 3, you get this much, and for product 4, you get this much. You add them up, this is a total benefit. This is a total gain, net gain, right? You want to maximize y. I think this is clear that what we want to maximize y, because we want to maximize the benefit. Subject to, now let's think about constraints. What constraints we have? Okay, first, the demand. So if you look at this right here, this is the minimum demand by consumers, or by the clients, or the customers. They want minimum 38,000 barrels a day. So I have to meet that one. That means what I have to generate is always, well, I don't want to generate more than 38. I want to generate maximum 38 to at least sell everything. If I want to sell everything, then I have to generate below what people is asking. Customers are asking 38 barrels or 38,000 barrels a day. If I generate less than $38,000 a day, then I can sell all of my products, right? So 15% of X1 is gasoline, 55% of product 2 is gasoline, 30% of product 3 is gasoline, and 25% of product 4 is also gasoline. Out of all the gasolines, this should be less than 38,000 barrels a day. So that's how we can get the first constraint. The second one, 25% of X1 is diesel fuel, 20% of X2 is, again, diesel fuel, 30% of X3 is diesel fuel, and 35% of X4 is diesel fuel. All these percentages are coming from this line. You see 25%, 20%, 30%, 35%. You multiply by X1, X2, X3, X4 should be less than 18,000 barrels a day. We dropped 1,000 because thousands are hidden in X1 and X4. All right, so we can continue writing all the constraints and put them in a spreadsheet, and I'll show you in a minute how we can solve that. Okay, So stay tuned and thanks for watching for the next part on solving this problem.